Another topic in Unit 1 was parallel lines being cut by a transversal and talking about the angles they form. So whenever you have a picture like this, you have two lines that are being cut by a transversal. We have all different types of angles that are formed, but when these lines are parallel, so if I mark M and N parallel to each other, well then that means that we have congruent angles and we have some supplementary angles. So exterior is the region outside of the two parallel lines. Interior is inside the two parallel lines. And when we say alternate, we're talking about this transversal here, so opposite sides of that transversal. So alternate interior angles are angles that are in the interior on the opposite sides of the transversal, so 3 and 6, 4 and 5. I also think of alternate interior angles as angles that form a Z shape. So you really want to look for that. Alternate interior angles are probably the most common in triangles, and you're going to see them a lot throughout the year. So the Z shape, look for that. You see the Z shape here between the 4 and the 5. It's kind of a backwards Z. But that tells me that if the lines are parallel, well, then those angles are congruent. We also have alternate exterior, so that's going to be 1 and 8, 2 and 7, opposite sides of the transversal and the exterior. Those would be congruent if the lines are parallel. Corresponding means if you take the top half of the diagram and you slide it down, which ones match up. Also think of it as when you talk about corresponding parts of triangles, it's the parts that match up. So 2 matches up with 6. It's in the same position of the diagram as 6. 4 and 8. So if you were sliding this down, the ones that match up, 1 and 5, 3 and 7, those are all corresponding. They would be congruent only if the lines are parallel. We also have down at the bottom supplementary same side interior angles. So 3 and 5 are same side interior, 4 and 6 are same side interior. Those are supplementary only if the lines are parallel. Same side exterior angles, so 2 and 8, 1 and 7, those would also be supplementary. So that's kind of the unique one, the same side. So anytime it's same side, think supplementary. So same side interior, same side exterior are both supplementary. The last thing here, down at the bottom, it says the converses. So if you change the order of these statements, they would also be true. So meaning if I started with the conclusion, I could imply what I was given here. So meaning if I say corresponding angles are congruent, well then that would prove that the lines must be parallel. So they go hand in hand. You can only have congruent alternate interior angles if those lines are parallel, or vice versa. So if they're parallel, then the angles must be congruent. So that's going to be something you want to keep in mind when we get to our examples. So on the next page, we have 2 examples. One is very basic, and then 2 is a little bit more challenging. So let's look at the first one. First thing is I see that the lines are parallel, so I can mark those. So now I have my 2 parallel lines cut by my transversal. And right away I see that these are on opposite sides of the transversal and they're in the interior. I also see the Z shape here. So that tells me that these are congruent because the lines are parallel and because they are alternate interior angles. So I want to write that out. Parallel lines imply congruent alternate interior angles. And you've seen this reason in proofs, but you have to make sure that you say that they're congruent because that's what the parallel lines are for. The parallel lines are telling us that those angles are congruent. Otherwise, you can just call them alternate interior angles, but there's no conclusion about them. So now that they're congruent, I can set them equal. So 2x minus 10 equals 65 minus x. I'm going to combine like terms here. I'm going to add the x over, add the 10 over. So I get 3x equals 75. Divide by 3, I get x equals 25. And my question just asked me to find x, so that's it. So that's all you have to do for that one. The next one's a little bit more challenging, and it's actually an old Regents question. So they tell us that they're basically just describing the diagram, but this part right here is going to be important, that GH and IH are congruent. So let's go ahead and mark that. And they also give us down below some angle measures. So EGB, so EGB, making sure that you're being really careful about labeling the correct angles. DIG, so DIG is 110. And your goal is to prove or explain why those two lines must be parallel. So I'm going to go ahead and highlight those two lines. So why would AB and CD have to be parallel? So the first thing I see is this segment EF is going to act as a transversal, because now I have my two lines being cut by a transversal. They give us angle 40 up here, which touches the transversal. So that's going to be an important angle to keep an eye on, because that might be a one of the congruent corresponding angles, or one of the congruent alternate interior angles that we're going to be able to get, or congruent alternate exterior. It is in the exterior, so maybe I could prove that this angle down here is 40, which would then mean that those are congruent alternate exterior angles, proving that those lines are parallel. Or maybe I could prove that this angle and this angle equal 40, which means those are corresponding angles, which if those are congruent, then the lines have to be parallel. So our goal is going to try to find another angle 40 that's either a corresponding angle or an alternate exterior angle, so that I can prove that the lines are parallel based on that. So let's start with this 110 here. I have 110 here for a reason, and I also have two congruent sides for a reason. So if we start there, then we'll try to get a 40-degree angle somewhere else. So let's start with that 110. So as soon as I see 110, I know that I can find this angle here, because these two angles form a straight line, so they have to be supplementary. So I'm going to just kind of number my steps, because we have to explain, so we have to make sure we don't leave anything out. So I can say, let's call this angle 1, so we don't have to use 3 letters. So I'm going to say that the measure of angle 1 is equal to, so I know it would be 70, because 180 minus 110 is 70, because angle 1 and angle DIG are supplementary, and 180 minus 110 gives me 70. So that's how I made that conclusion. So when I'm explaining, I'm just kind of doing the math and explaining how I know. So this is going to be 70. Now I also see that this triangle right here has two equal sides, meaning it's an isosceles triangle, which means it has two congruent base angles. So this angle and this angle would have to be congruent, because they're base angles in isosceles triangles. So if this is angle 1, this is going to be angle 2, which means if this angle was 70, this angle is going to be 70. Let me switch colors on that. So this is 70, this is 70. And make sure that you're using those as your base angles, because you're going across from the congruent sides. So I can now say that triangle IHG is isosceles because it has two congruent sides. So this tells me angle 1 is congruent to angle 2. Then we said that angle 2 is equal to 70, since angle 1 was equal to 70. I'm just going to put those in blue so it shows up a little bit. So now I could figure out angle H, because I have a triangle and all 3 angles in a triangle have to add to 180. I'm going to put angle 3 here though, because I don't want to say angle H, because there's more than one angle H. So now I can say, since all 3 angles in a triangle add to 180, and 180 degrees minus 70 minus 70, so 70 plus 70 is 140, so 180 minus 140 is essentially what I'm doing, is 40. That means that the measure of angle 3 is equal to 40. So that's going to be, we got 40. So now we got to look at how does that relate to that other 40-degree angle. So this is 40. So let's look at up top here. So 40 is there and 40 is here. How do those angles relate? So here's my two lines, here's my transversal. 40, if you imagine sliding it down, it would overlap with this 40. So those are corresponding angles. If you have congruent corresponding angles, then that forces those lines to be parallel. So now I can jump to my conclusion and say that those lines are parallel because I have congruent corresponding angles. So AB is parallel to CD because angle 3 is congruent or is equal to 40 and angle EGB is equal to 40. So angle 3 is congruent to angle EGB, and congruent corresponding angles imply parallel lines. So we're doing the converse of what was on the previous page. So we got the congruent corresponding angles, which verified that those lines have to be parallel. Now you could go further with this, and instead of using corresponding angles, you could have said, well, if this is 40, then this is 40. That's because vertical angles. And then you could have said, well, 40 here and 40 here, those are alternate exterior angles, and if those are congruent, then the lines are parallel. So either way, you could have used this angle 40 for corresponding angles, proving the parallel lines, or alternate exterior angles to prove the parallel lines as well. So you don't have to have this word for word, but you have to have the same general idea. So you have to just make sure you're getting your measurements and you're explaining how you're getting them. So that's the idea of this problem.